The spouse of a certain US government employee who lives in Washington, D.C., posts a nice little picture to her social media account, showing the beautiful greenery just outside of her house. Now, your task as a Russian agent is to track this man down using just the information you have from the photo. Note that if you try doing it the easy way, using Google or Yandex reverse search, it won't get you anywhere, so you'll have to use something a bit smarter. Now at first sight you don't see anything unusual, but if you look a bit closer we can see a few details. One, there's the house itself. Looks quite ordinary, nothing too identifiable on it, no road signs, no logos, but we can see it's a typical detached house, so that might be useful later on. Secondly, obviously we've got the sign. There, if we zoom in, we can see it says no parking, but the thing that interests us the most is the last sign. If you look a bit closer, it says school something, 4 letters. But that's all we need. It shows us there's a school nearby, and it's probably just outside the fence. So that's something we can also use later on. And last but not least, there's the bin just to the side of the road. Now, a lot of the bins are mapped as entities on OpenStreetMap, and that leads us to the next point of how we're going to do this. So, we go and open a certain tool called overpass-turbo. Now, this is based on OpenStreetMap, which forms its foundation, but allows us to use programming to make use of it and to find interesting location. Note that here we're using the Russian mirror to ensure that we're not blocked and the page loads faster. So now let's see how it works in action. First we set a time limit to our query, that 60 seconds should be enough, and the geographical area, which is obviously Washington DC from our preliminary information. Then we go and find all schools in the area. So we iterate through all nodes, ways and relations, which are the 3 ways open source OpenStreetMaps can store locations, so all of them are needed. Secondly, we iterate through all bins in the area, which, due to how the map is run and due to different editors running the map, can be both a wastebasket and a trash. So that's how things are also here recorded. Then we find all detached houses in the area. And note, the indentation isn't really important, but as long as you get the stuff in, it should be good. We look through all buildings that are houses and all buildings that are detached, just in case. And now another important part, we convert houses to points for distance calculations. And of course, the thing that's going to help us identify is finding houses within certain distances. Now that is 30 meters within bins and 40 meters within schools. That should be more than enough for us to find what it is. If we quickly go back to our picture, you can see that that is approximately the right distance. No special tools needed, just judging from common sense. And of course it's always better to overshoot than to undershoot it, or you risk losing precious data. And finally, output the results into text that we can read. Now let's run the query and wait a bit. Now the query has run and we can see the results that we finally got. There's 1, 2, 3, 4, 5, 6, 7, 8 locations in total of the schools it found. So let's look at the streets around them. One of them, right at the center, shows a few houses, but straight away we can see it's not the one because the house isn't detached. And more importantly is that the road layout is also way different. Here you can see the roads are completely perpendicular to the adjacent road. And again, going back to the picture, we can see that the house is located next to one road that's directly across from the school. So you can see it's right here, and the school is just across the road. Going back here again, the school is literally just over the parking lot, which obviously isn't the case. Now go a bit further to the next location. Here again, same story. the houses are terraced, and the school, although the school is located directly across. So that could be actually a place of interest. Maybe, we didn't guess the right angle, so let's look it up. There it is. Look at the picture, but it looks a bit different, and you can even walk around here. The houses are just not the right way that we want them. So never mind, we know we've got our query correct, so we'll keep going. This one, quite interesting. It's at an intersection, but again, the school is located diagonally. That's not ideal. Going up even more. Same story, but there's not even a school here. There's a field, so it's probably something that doesn't even work. And looking at this one in Tacoma. Now here again, we see something interesting. So there's a bin, quite visible. There's a school, and there's a side road going into the main road at an angle. Going back here, that seems also quite probable, with a stop sign also. We haven't actually mapped out the stop sign right over here, but it shows us something interesting as well, that due to the rules of the road in the US, the stop sign has to be in front of a side road going into a main road. So that's also a very probable location. Let's go and look into Tacoma Elementary School. And there we are, going into Google Maps. We see something very, very familiar. Now, obviously, it's in Russian here because we're Russian hackers, but either way, going and looking around, we can see it's the one. And if we want the exact address of this man's house, we can already see it right over here. So there's that. The first location is done. And of course, this is just one of the techniques used in Russia and, well, many other countries, to be frank, that could be used for intelligence work using completely free and open source tools available fully to the public. Now that we've found where this man lives, we switch over from the US suburbs to the Swiss countryside to track down another practical case. So Viktor Korchnoi was a Soviet chess player who defected to Switzerland in the 70s, and your task as a KGB spy is to hunt him down. Now, a local newspaper has posted a black and white photo, as obviously remember we're in the 70s, to see where he's staying at. Now, this is a hotel, and this is where he lives. This is again all you've got, and posting it in Yandex or Google reverse search won't get you anything. Don't worry, I have tried. Again, identify the details, which we can see over here. Obviously, aside from the restaurant itself, we've got the bridge. And not just any bridge, it's a covered bridge, since it's got a roof on it. That again might be a nice detail we can use. Secondly, look at the gates over there, and it's a classic cattle gate. You see those used in Switzerland quite a lot in rural areas to stop the cows from going on the main roads and blocking the traffic. So again, another nice detail. And thirdly, you can see signs going in this direction and in this direction. All in all, this is a classical Swiss guidepost, if we can look at it, usually located next to a map, which makes sense. So again, on many hiking trails in Switzerland, you've got the guideposts to show them the way. Those are also very frequently mapped as certain locations on the OpenStreetMap website. So you can also use that to identify. Now again, there's a few other details here. You can see the road sign, obviously the mountains themselves, but again, without precise location, without concrete information, they're not going to get you anywhere. So let's go back to Overpass Turbo and center in on Switzerland to see what we can find. Let's first make a slightly longer timeout than before, since it might take a while to search. Obviously the area is quite a bit larger than just Washington DC, so it might take us longer to find. And by the way, here we're using the German name for Switzerland, which is Der Schweiz, because the English one simply won't work. Again, how OpenStreetMap works is that it preferences the local language first, since it's all done by volunteer editors. And secondly, now we gather the reference points. So first we've got the guideposts, then we have the cattle grids, thirdly we've got the covered bridges, again just like last time, showing the nodes, ways and relations to not miss anything. And now finally show all restaurants and hotels that meet all conditions based on our distance. Now here as well, it's good to know a little bit of programming, so people who've seen the symbol before know it's a pipe and it's an OR statement. Basically searches for restaurants or hotels in one query, so we can all do it very neatly. Now the guideposts are about 50 meters away, cattle gate 80, and covered bridge about 200 from the target location. And also bear in mind, with the distances we can see here, is that it measures from the edge of the zone. So usually, if we see before, from our example in Washington, houses are a rectangle, or any polygon for that matter, but they measure from the edge. Even then, again, it's always better to overestimate than to underestimate, so that's why we've got those location points. Oh yeah, one thing I forgot to mention is to obviously output the results. We need to output them into a body, and using Qt, draw the actual circles in place to see what we're looking at. Now let's run the program and see what it gives us. And there we go, the code has finally run, and we're lucky to output one location that might seem about right. So let's check. We can actually click on the node and see what details it have. So here it found that the Amity is a restaurant, the name of it as well, which might be useful, and also wheelchair accessibility. Obviously we couldn't judge that just from our photo over there. As you can see, we didn't have any like wheelchair signs or anything, but there we have it, yeah, limited wheelchair accessibility. Now let's look it up. So this looks like Gasthaus Sege. Or actually even, let's just zoom in on the map right there, because again, it might not be mapped directly. So we can see it's to the southeast of Bern and to the east of Thun in Switzerland. Eritz, yep, that was the nearest city. And just along the road, Restaurant Sege. There we go. And again, putting Google Maps, Google Street View, and there we go. Currently the location still looks very much the same. Obviously, if we turned around a bit more, we could have gotten much more to work with, but obviously if that's the photo all we had, we still found the location. So again, going down a bit more, we can confirm it still is the one, and yep, it looks just fine. So there we have it. Just with limited information, we found the exact location where the chess player is staying at, and we've solved our task. So again, a few tips on how you can do this yourself in cases where you might need to use these tools is, firstly, there's a link with all of the documentation itself of how Overpass works. I'll post a link in the description for you to look at. And also, if you're having trouble writing the code itself, obviously AI can help you with that. Now, inside of the website itself, there's an AI wizard that can help you turn natural language into code, but it's quite limited. So again, you can go into ChatGPT, you can go into DeepSeek, and help you debug some code, maybe if you're having issues, or even just create a query off by scratch, and most of the time it might work. Again, frequently I notice that you do need to correct it, but either way it can be a nice tool to help you get the job done quicker. So thank you for watching the video, and if you want more content like this, then drop me a comment down below, and I'll see you in the next one.